Hello students, welcome in Babita Science tutorial and let us start our new topic of chapter 1 matters in our surrounding, and this is part 7. In the previous topic we have discussed about the uh, change of states of a matter, and we can also say that we can change the physical states of matters in two ways. First one is by changing the temperature and by changing the pressure. In the previous topic we have discussed all about the fusion, also the process in which solid substances changes into a liquid on heating is called the fusion, or we can say that it is a melting. But today's our topic is what happen when a solid melts. Its temperature remains the same. So where does the heat energy go? Okay. Suppose that when you will convert the ice is in the solid forms. When we convert the ice into the liquid, then temperature inside the ice will remains the same. It will not increase. How? Now in this topic we will study about the temperature. Where does the heat energy go? Let's start now. Now in this paragraph, see in this paragraph, you must have observed during the experiment of a melting that the temperature of the system does not change after the melting point is reached till all the ice melts. This happens even though we continue to heat the beaker. That is, we continue to supply heat. The heat gets used up in changing the state by overcoming the force of attraction between the particles. Students, here they want to say that when you will heat, this is a beaker and here is a ice. Okay, this one is a ice. When we heat this beaker, okay, when we heat this beaker with the help of the burner, okay, then this ice is converted into the liquid. This height is converted into the liquid, but temperature will not increase. Temperature will not increase. No. Why? Then students, here, as this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the content of the beaker and known as a latent heat. Very important topic is here, latent heat. Then sometime question will ask to you, what is a latent heat? Actually the word latent heat means, or latent means a hidden. Latent means what here? The hidden heat. Okay. So when you will heat the beaker in which ice is present, but it will not increase the temperature. No. Why it will not increase the temperature? Because this heat is hidden into the contents of the beaker. When we supply the heat, see here, this one is a beaker and this one is a ice. When we heat this beaker with the help of the burner, then what happened? This heat goes inside the contents of the beaker, and that heat is called the latent heat. And this latent heat is not helps in the increasing the temperature. That is called the latent heat. And the definition of the latent heat, we can say that the heat energy which has to be supplied to change the state of a substance is called the latent heat. Ice is in the solid form. When we will apply the heat here, this ice is converted into the liquid. Why? Due to the latent heat only. Then we can say that latent heat is the is comes under that the heat energy which can be used to convert the state of the matter. And the latent word means here hidden. Then if question will ask to you define the latent heat, then you will write this one definition. Now students, the temperature of substances the temperature of the substance remains same in the beaker after supply of a heat due to the latent heat. Now latent heat is of a two types. First one is the latent heat of a fusion, and second one is the latent heat of a vaporization. Now see here, here is 270 have this one latent heat of a fusion. The latent heat is of two types. First one is a latent heat of a fusion, and the second one is a latent heat of a vaporization. Now see here in another paragraph it is given here latent wait a minute here, latent heat of a vaporization. Now here it is a two type of a latent heat of a fusion, and another is a latent heat of a vaporization. Let's discuss one by one. Now what is a latent heat? Then what it is a latent heat of a fusion? Then the students here definition is given here. Latent heat of a fusion is the amount of heat energy that is required to change the 1 kg of a solid into a liquid at atmospheric pressure at its melting point is known as the latent heat of a fusion. Because fusion means what? Fusion means a melting, means those temperature means we can need a temperature that can change the 1 kg of a solid into a liquid at a atmospheric pressure at its melting point. Then we can say that it's a latent heat of a fusion. Now students, I told you that melting point of a water in degrees Celsius is a 0. But if I will ask to you what is the melting point of a water in Kelvin, then you can see that it is a 273 Kelvin. Why it is a 273 Kelvin? Because when we add the 0 plus 273, then it is equal to the 273 Kelvin. Because Kelvin is the another unit of a measuring temperature, and it is denoted by the capital K. So students, here it is your latent heat of fusion, okay, and the melting point of a water in Kelvin is 273 Kelvin. If I will ask to you what is the boiling point of water in Kelvin, then what you will do here, then in the Kelvin, now you will add a 100 plus 273 equal to, it is a 373 Kelvin. So this is a boiling point of a water in Kelvin. Then we can say that the boiling point of a water in Kelvin is 373 Kelvin. But in the degree Celsius, boiling point of water is 100 degree Celsius. Now let's move to another paragraph here. In the another paragraph says that when we supply heat energy to water, particles start moving even faster. At a certain temperature, a point is reached when the particles have enough energy to break free from the force of attractions of each other. At this temperature, liquid start changing into a gas. Now student, I told you about the vaporization, also latent heat of fusion, and another is a latent heat of a vaporization. Means when we supply the heat energy to water, then the particles start moving very faster, and at one point what happened, the force of attraction between the particles start breakdown. No, then what happened? The temperature at which a liquid start boiling at the atmospheric pressure is known as its boiling point. Another definition is here boiling point. Means those temperature in which liquid start to boil at the atmospheric pressure is known as a boiling point. And here is a melting point. Means the temperature, the minimum temperature at which solid melts to becomes a liquid at the atmospheric pressure is called the melting point, and here is the boiling point. And boiling is a bulk phenomena. No? The bulk of the liquid gain enough energy to change into the vapor state. Students, here you will see here how to convert the degree Celsius into the Kelvin. Now boiling point of the water is 100 degrees Celsius. Now you have to convert it into the Kelvin. The what you will do here, you will add the 273 plus 100, then it is equal to the 373 Kelvin. This is how to convert the Celsius into the Kelvin. You will just add it 273. No, now another and it is a very easy to convert the Celsius to Kelvin. Okay, if question will comes to you how to convert the Kelvin to the Celsius scale, then what we will do here, suppose that 300 Kelvin is given and you have to convert the Celsius scale. Then 300 Kelvin is given here, and temperature on the Celsius scale you have to find out. Then what you will do here, just you will minus it from the 300, then you will get the temperature in the Celsius scale. Now in the last paragraph, it is a latent heat of a vaporization. Now simply students, the same thing, vaporization means when the water is converted into the liquid, when the water is converted into the steam, that is called the latent heat of a vaporization. Now see here, have to define the latent heat of a fusion particles in steam, that is a water vapor at 373 Kelvin have a more energy than the water at the same temperature. No, temperature is the same here. This is because particles in steam have absorbed extra energy in the form of a latent heat of a vaporization. Now question is here, students, that boiling point of the water is 100 degrees Celsius, but the water vapors has a more energy, has the more heat energy as compared to the boiling point of a water. So this is because particles in steams have absorbed extra energy in the form of a latent heat of a vaporization. So here given that how to convert the solid into liquid and liquid into the gas. No, then see here solid state. Then solid state is a, when we'll heat it solid state, then it will convert it into the liquid state, and when we heat the liquid state, then it will convert it into the gaseous state. Now students, when will cool the gaseous state, then it is converted into the liquid state, and when will cool the liquid state, then it will convert it into the solid state. Then in this chapter we have a study about the latent heat. Now types of latent heat is the latent heat of a fusion and latent heat of a vaporization. Then I hope you will understand here very nicely. And how you will convert the degrees Celsius into the Kelvin by adding just 270 thing, you will easily convert it. And another thing, when Kelvin is given and you have to convert it into the degrees Celsius, then what you will do here, you will just minus the 273 from the Kelvin, then you will get the answer into the degree Celsius. Then this is about the latent heat and the latent heat of a fusions and the latent heat of a vaporization. Then fusion is a what, students, here when the solid is converted, the heat energy which is required to convert the solid state into the liquid state, that is called your uh, latent heat of a fusion. And same thing here, the heat energy which is required to convert the liquid state into the water vapor, that is called the latent heat of a vaporization. No, then this much about, okay, in the, okay students, something is left here. See here in see the notes here, in this one notes, here it is given written something about the Kelvin. See here, Kelvin is the SI unit of a temperature. 0 degrees Celsius to 73.15 Kelvin means what here? Here it is talking about the boiling point, sorry, melting point, because the melting point of a what is the 0 degrees Celsius, and when you have to convert the 0 degrees Celsius into the Kelvin, then you can just add it here to 73. And then after it is written here to 73 Kelvin after rounding of the decimal. To change the temperature on the Kelvin scale to the Celsius scale, you have to subtract 273 from the given temperature. I already explained you about this one. When you will convert the degree Celsius into the Kelvin, you will add it 273, and when you have to convert the Kelvin into the degree Celsius, then you will just subtract this 273. Then you will easily convert the Celsius scale into the Kelvin scale and Kelvin scale to the Celsius scale. Student, this is about latent heat of fusion, latent heat of evaporizations, latent heat, and how we can convert the states of matter. We can convert the state of matter by applying the temperature and pressure. So this is only in this video. I hope you will understand. If you have problem, then comment me in my comment box. I will reply you. And till then, bye. Have a nice day.